Hello, good day. I am Mubarak Timalotang, and my presentation is about UML dynamic modeling rotations. So let's start about what is UML. UML is not a programming language, but it is rather a visual language. The general purpose of UML is to define a standard way to visualize the way a system has been designed. It is quite similar to blueprint used in other fields of engineering. UML diagrams used to portray the behavior and structure of a system. Also, UML helps software engineers, businessmen, and even systems architects with modeling, design, and analysis. UML guides the creation of multiple types of diagrams, such as interaction, structure, and behavior diagram. Why we use UML? Because simplifies complex software design, can also implement OOPs like a concept that is widely used. It reduces thousands of words of explanation in a few graphical diagrams that may reduce time consumptions to understand. Also, it makes communication more clear and more real. It becomes very much easy for the software programmer to implement the actual demand once they have the clear picture of the problem. Also, businessmen do not understand code. So basically, UML becomes essential to communicate with non-programmer essential requirements such as functionalities and process of the system. And the one of the reason why you use UML is because it integrates the best practices. UML diagram type. UML diagram type have two types. The first is structural, as known as the static. Structural emphasize the static structures of the system using object, attributes, operations, and relationship. It includes class diagrams and composite structures diagram. In the behavioral, or as known as the dynamic, emphasize the dynamic behavior of the system by showing collaboration among objects and change to the internal state of objects. Behavioral captures the dynamic aspects or how objects communicate with each other, how the passage of times affect the system, or what events cause the systems to change internal states. Now, we have the UML diagram which represent the structural and behavioral. Under structural, we have the composite structure diagram and deployment diagram, package diagram, profile diagram, class diagram, object diagram, and the last is the component diagram. On the behavioral diagram, we have an activity diagram, use case diagram, state machine diagram, sequence diagram, communication diagram, interaction overview diagram. And also the last is timing diagram. Now let's tackle each of them. Let's start about composite structures diagram. Structural diagram or structural diagram composite used to show the internal structures of a class. So like in the image, we can see that we have the students and teachers. it shows the internal of each one. Now we have the deployment diagram, which is shows the hardware of your system and software in that hardware. Deployment diagrams are useful when your software solution is deployed across multiple machines, with each having a unique configuration. So we can see on this graphical image, we have the web server and the device. In the web server, we have the vehicle registration, and the three devices, we have database save server, application server, and main computer. Each of them connect to each other. Now, we have the struct package diagram. As the name suggests it, a package diagram shows the dependencies between different packages in a system. So we can see we have the HR folder or package which contain employee details and adjust accounting. So it connects on accounting, which accounting have an add accounts or it also remove the accounts. So in the invoice, we have the customer's invoice and supplier invoice. Now, we have the profile diagram. Profile diagram is a new diagram type introduced in UML Tools. This is a diagram type that is very rarely used in any specification. Class diagram, which is part of structural diagram, are the main building object of any object-oriented solution. It shows the classes in a system, attributes, and operations of each class, and even the relationship. Now we have this object diagram, or sometimes referred to as instance diagram, are very similar to class diagrams. Like how class diagrams, we also show the relationship between objects, but they use real-world examples. So object diagram is more like an real-world of how it defines of each classes or attribute. In the structural diagram, we also have the component diagram. It displays the structural relationship of components of a software system. These are mostly used when working with complex systems with many components. Like components communicate with each other using interface. The interface are linked using connectors. Now, let's tackle about the diagrams under behavioral. At first, we have the activity diagram, which represent workflows in a graphical way. It can be used to describe the business workflow or even the operational workflow of any components in a system. Sometimes, activity diagrams are used as an alternative to state machine diagram. We also have the use case diagram, most known diagram type of the behavioral UML types. Use case gives a graphic overview of the actors involved in a system, different functions needed by those actors, and how this different function interacts. State machine diagram is a similar to activity diagram, although notation and usage change a bit. They are sometimes known as a state diagram or state chart diagram. As well, these are very useful to describe the behavior of objects that acts differently according to the stage you are in at the moment. Interaction diagrams are very similar to activity diagram. While activity diagram shows a sequence of process, interaction diagram, however, show a sequence of interaction diagrams. Now we have the communication diagram used to show sequence message exchange between an object. A communication diagram focuses primarily on objects and their relationship. We can represent similar information using sequence diagram. However, communication diagrams represents objects and links in a free form. Now the last is we have the timing diagram. Timing diagram, special form of a sequence diagram, which are used to depict the behavior of object over a time frame. We use them to show time and duration constraints which governs change in states and behavior of object. Now let's tackle about the sequence diagram notations. Sequence diagram notation have an actor which represent a type of a role where it interacts with the system and its object. It's important to note here that an actor is always outside the scope of the system. Sequence diagram notation also have a lifeline. It depicts an individual participants in a sequence diagram. So basically, each instance in a sequence diagram is represented by a lifeline. So this is what lifeline looks like. And the last, we have the message. Message communication between objects is depicted using message. The message appear in a sequential order on the lifeline. We represent message using arrows. Lifelines in message form the core of sequence diagram. Also, message have a different categories, which we have the synchronous message. Synchronous message, it waits for a reply before the interaction can move forward. Asynchronous message does not wait for a reply from the receiver. The interaction moves forward irrespective of the receiver processing the previous message or not. We use a line arrowhead to represent an asynchronous message. Create message is to instantiate a new object in the sequence diagram. There are situations when a particular message call requires the creation of an object. It represents with a dotted arrow and created word labeled on it to specify that it is create message symbol. We also have delete message. To delete an object, when an object is deallocated memory or is destroyed within the system we use, the the delete message symbol, it destroys the occurrence of the object and the system. It is represented by an arrow terminating with an X. We also have a self-message. Some certain scenarios might arise where the objects need to send a message to itself. Such as message are called self-message and are represented with U-shaped arrow. We also have reply message, which show the message being sent from the receiver to the sender. We represent a return or reply message using an open arrowhead with a dotted line. The interaction moves forward only when a reply message is sent by the receiver. Found message represents a scenario where an unknown source sends the message. It is represented using an arrow directed towards a lifeline from an endpoint. And the last, we have the lost message. Lost message represent a scenario where the recipient is not known to the system. It is represented using an arrow direct towards an endpoint from a lifeline. And the last, we have the guards. Guards used when we need to restrict the flow of message on the prefix of a condition being met. Guards play an important role in letting software developer know the constraints attached to a system or a particular process. Now, let's talk about the UML tool. UML Tools is a software application that supports some or all of the notation and semantic associated with the Unified Modeling Language, which is the industry standard general purpose modeling language for a software engineering. A larger number of a case or computer-aided software engineering tools for UML currently exist. And here is the most widely known use are Rational Rows. Rational Rows, an object-oriented UML software design tool intended for visual modeling and component. Software designer use rational rows to visually create the framework for an application by blocking out classes with actor, use case elements, objects, and message or relationship in a sequence diagram using a drag and drop symbol. Rational rows has the most popular features of which is it allows the designer to take advantage of iterative developments, sometimes called evolutionary developments, because the new application can be created in stage with the output of one iteration becoming the input to the next. However, the developer began to understand how the components interact and makes modification in the design. So rational rows can perform what is called a round-trip engineering by going back and updating the rest of the model to ensure the code remains consistent. Now, Argo UML is an active open source project that provides a working tool to support basic UML modeling activities. The diagramming features are easy to use and provides useful assistance in the formatting or aligning process. The nicer aspects of Argo UML lie in its design assistance feature. The design evolution and checklist provides a valuable help to make sure that your model are well formed. And the last tool, UML tool, we have the Together J. Together J integrates codes and diagrams, which is it also capable of enabling changes to code displayed in one window to be immediately reflected and changed to a UML diagram displayed in other, also a vice versa. And here is the reference about my presentation.